Ladies and gentlemen, please move as close to the center of your row as possible. If there are any vacant seats between you and the next person, please stand up and move over so that all vacant seats toward the center of that row are filled. Thank you.
That was the gentlest statement to move in towards the center you'll ever hear. I could barely hear it myself, but if you would, there are a few more people coming in, so those on the edges, if you could move in a bit. Also, you'll get a better view of the screen. Good evening. I'm Ted Maxwell. I'm Associate Director here at the museum, and it's a real pleasure to welcome you tonight to the lecture. And let me just tell you a little bit about the lecture. It's named for John Bacall, and I believe we have his picture up here. And this is the second John Bacall lecture that's sponsored by the Space Telescope Science Institute. John was a PhD from Harvard University. He was a member of the Institute for Advanced Study at Princeton. He was a member of the American Astronomical Society, the National Academy of Sciences. He won the National Medal of Science and the Bernhard Lecture and Medal from the Royal Swedish Academy of Science, among dozens of other awards. But the reason this lecture is named for him is for his work for well over 20 years with the Space Telescope. And I can only imagine probably 35 years ago, maybe 32 years ago, somebody saying to him, "You want to put what, where?" Nonetheless, he was a tireless worker for that, and it's a real honor to him, and I think it's great for the Science Institute to name the lecture for him. Tonight, we have Geoff Marcy, who is a professor of astronomy at the University of California, Berkeley, and he's adjunct professor of physics and astronomy at San Francisco State. But really, he's director of Berkeley's Center for Integrative Planetary Science, and that's a research unit that studies the formation, geophysics, chemistry, and evolution of the planets. Geoff's research focuses on the detection of extrasolar planets and brown dwarfs. His team discovered the majority of the 250 known planets around other stars, including the first multiple planet system, the first Saturn mass planets, and the first Neptune mass planet. And like John Bacall, Geoff is a recipient of numerous awards, including the Shaw Prize in 2005. He was Discovery Magazine's Space Scientist of the Year in 2003. He's won the NASA Medal for Exceptional Scientific Achievement, the Carl Sagan Award, the Beatrice Tinsley Prize, the Henry Draper Medal from the National Academy of Sciences, and he's also a member of the National Academy of Sciences. And I'm going to stop there. Or we wouldn't have time for his talk. But tonight's lecture is New Worlds, Yellowstone, and Life in the Universe. And the lecture is supported by NASA Goddard, and of course by the Space Telescope Science Institute. So please help me in welcoming Geoff Marcy.
It's an enormous honor for me to be here to try to help celebrate John Bacall. I can only tell those of you who perhaps didn't know him personally that John Bacall was an inspiration to thousands of scientists throughout the world, and for me personally played a very important role in supporting me when I was very young, and he gave me encouragement, and I know that my story is the same for many, many other scientists who he helped along, in addition to the vast number of other activities that John Bacall participated in. So I feel, frankly, a little humbled and even embarrassed to try to give a talk that has John Bacall's name on it. But I will try to do him some credit by letting you know the exciting developments of a subfield of science that has just exploded in the last few years. Exploded in the sense that a new field has encroached into other fields, disciplines of science, captured in part by the title of the talk, I'm going to try to tell you a little bit about the first discoveries of planets around other stars and what those planets are like, how they bear on the habitability that we find here on Earth for life, and then hence the prospects for finding life elsewhere in the universe. I can't help but start with our own home, the Milky Way Galaxy. Of course, all of you know that the Milky Way contains some 200 billion stars. It's 100,000 light years across. If you shine a laser pointer in the Milky Way Galaxy at night, it will take 100,000 years for the light beam, your laser light beam, to make it all the way across the galaxy, traveling at 186,000 miles per second. But while those are the facts of our Milky Way, what I find most profound is that the laws of physics and chemistry and mathematics that every freshman learns in college pertain equally well across the Milky Way Galaxy. The laws of gravity, electricity, and magnetism, quantum mechanics are the same here on this planet, Earth, as they are clear across the galaxy 100,000 light years away, suggesting that the physical properties of our Earth and our host star, the Sun, are probably physically similar and reproduced elsewhere in our galaxy. Why would the physics or chemistry here locally be different from what we find elsewhere? And that has led humans for a very long time to suspect that there are, in fact, perhaps other Earth-like planets elsewhere in the galaxy. What we don't know is whether or not there are universal laws of biology. Is there a single equation that you can write down pertaining to biology here on Earth that you are positive applies to the extent of our galaxy and beyond into the universe? I would suggest there isn't such a law. We, for example, don't know whether or not liquid water is the prerequisite for life elsewhere in the universe as it is here on the Earth. We certainly don't know whether there are any other replicating molecules that code for the structure of life from generation to generation, as DNA does here. Is that the only such molecule that can do the job? And I think most profoundly, and indeed humbly, we humans don't know whether we reside at the pinnacle of the Darwinian evolutionary tree, or whether instead we humans occupy some twig on that tree, some lucky fluke of evolution that took place on the East African savanna 2 or 3 million years ago. So we really don't know whether or not advanced intellectual, technological life is a natural byproduct of biology in general. And of course, our ignorance stems from the fact that we actually have, to this day, only one example of biology, life in the universe. Still to this day, only the Earth is the place where we've found life, not on any other planet, nowhere else in the universe as a whole. With only one example of biology to go on, we can't generalize. So we don't know what the rules of biology, and hence can't predict whether there might be biology elsewhere and what it might be like. And therefore, of course, NASA and other intellectual institutions are searching for life elsewhere. Of course, our own solar system, being right in our neighborhood here, represents the first stop in any such searches for life in the universe. Mars, of course, a planet with many attributes similar to the Earth, is a destination that NASA will be studying very actively in the next few years.